Hey, this is Mr. A, and this lecture is on SI units. SI stands for the system, basically the international system of units. It's an international standard. Now, why do you think we need to have a standard when we're talking about units of measurement? Think about that for a minute, and you might come up with the fact that you would want to agree with somebody on the unit of measurement if you were trying to say, I don't know, determine the size of this room. Now let's just say we had some weird unit called a foot, right? And the foot actually was the size of your foot. That was your quote-unquote standard. And you went and you measured the room by putting one foot in front of the other, and you determined that the room was going to be, I don't know, 10 feet by 20 feet. Now, would you have the same measurement as someone else using their foot? Well, no, you wouldn't, unless their foot was exactly the same size. So we have to agree upon some standard. It's not the foot. The standard, the international standard, is the meter. And we have talked about the meter before. It's the international standard for the measurement of length, right? And there are other things that we would measure. We would measure matter, mass of something, and we would measure the volume of something, and we would measure time. Those are all the kinds of things we're going to be talking about in today's lesson, SI units. So I trust that you have your paper out and you have set up your paper for taking Cornell Notes, and at the very top you would write SI units and the date that you are taking these notes. So as I mentioned, the base unit for length is the meter. That's what we're always going to reference to. So whether we're talking about centimeters or millimeters or kilometers, they're all referring to the meter, right? For mass, the standard base measurement is kilogram for time in seconds. You're familiar with that. And then temperature, Kelvin. So the first bullet in your notes, of course, is SI base units. And I want you to write down these base units because these are ones that you're going to have to be familiar with. The next point that I want you to write down is SI prefixes. I've already mentioned centimeter and millimeter. Those are all referencing the base unit, the meter. You're going to need to be familiar with all of them, especially these, kilo, centi, milli. This is the base unit, a meter. A centimeter is about, well, I said before that my thumb is the thickness of 2 centimeters. There are 100 centimeters in a meter, and there are 1,000 millimeters in a meter. So that's where we get centi and milli. And write in your notes that kilo has a multiplier of 1,000, that centi has a multiplier of 0.01, and that milli has a multiplier of 0.001. Now what do I mean by a multiplier? That means that if I have a measurement that is 1 kilometer, which is, in the English system, we would compare that to a mile, right? So that's a great distance, right? That would be, so when you traveled to school this morning, you traveled a distance in kilometers, right? You wouldn't use a meter to tell someone how far you came to school, or maybe you would. If you did use the meters, you would have to convert from kilometers to meters so that you would have to multiply. So if you lived, let's say, 5 kilometers away, then you would have to multiply by 1,000 to tell somebody how many meters that was away. So if you live 5 kilometers away, then you actually live 5,000 meters away. So that's what I mean by a multiplier. I want to make one more comment about SI prefixes. Actually, I just want you to make sure that you have in your notes these relationships, because this might not be as clear to you as this is. In 1 kilometer, there is 1,000 meters, okay? In 1 meter, there is 100 centimeters, right? And in 1 centimeter, there are 10 millimeters. I want to make sure that you have these relationships because we're going to be using them a lot. For a complete list of SI prefixes, you can Google that, or you can look in your textbook, and I'll give you the textbook reference at the end of this video. There's a memory aid that goes along with it. I want you to look that up also. King Henry died by drinking chocolate milk. That's a memory aid, which means that kilo, hecta, deca, deci, centi, milli. This saying King Henry died drinking chocolate milk helps you to remember all the prefixes, and then you'll need to remember the multipliers that go along with it. These are the most important ones, which we'll be using a lot, so I want to make sure that you get these in your notes today. All right. In just the previous slide, I told you how to convert 1 kilometer to number of meters, right? So 1 kilometer is 1,000 meters because kilo means that you're going to multiply by 1,000. I want to spend a little bit more time with that. So when you want to convert from one metric unit to another metric unit, you need to have a strategy or you're going to get lost. So here is my strategy for converting from, well, this is my strategy for tackling a lot of the kind of problems that we're going to tackle in physics, physical science, and astronomy. First, you want to write down what information you are given. Then you want to write down what is it that you want to know. Then you want to write down an equation. You want to find some equation that you're going to use. Then you're going to substitute the given information into the equation, and then you're going to solve the equation. I call it the guess method because I call this the guess method because it's the given information and the unknown and the equation and then substituting and solving. G-U-E-S-S. So we're going to guess in order to convert one metric unit to another. So for example, here's an example problem. What if I wanted you to convert the measurement of a 3,075 millimeter rope, but I wanted to know what that was in centimeters? Okay? You are given the fact that you have a rope that is 3,075 millimeters, right? What you want to know, what's unknown, is how long that rope is in centimeters, right? So we're going to need an equation for that. So what I want to write here is we know the length in millimeters. Length in millimeters times some conversion factor is going to equal length in centimeters. So here's my equation. So length in millimeters, okay, I got that. Length in centimeters is what we want to know, but what's this conversion factor? Well, the conversion factor is one length in the desired unit divided by an equivalent length in the given unit. Okay? Now that kind of sounds complicated, but what is the desired unit? What do you want to have the length of the rope in? We want it in centimeters, right? So 1 centimeter over the equivalent length in a given unit. So how many what is the given unit? The given unit is millimeters, right? These are my abbreviations for these standard units. How many millimeters are in 1 centimeter? Okay. Well, if this is a centimeter and you look and count the number of millimeters in it, there's 10. There are 10 millimeters in 1 centimeter. So this is your conversion factor. It's one length in the desired unit divided by the equivalent length in the given unit, right? So it's basically 1 over 10, right? So if this is your conversion factor, now you have your equation, and now you can just plug in what you know. So 375 millimeters times 1 centimeter divided by 10 millimeters is equal to is equal to 307.5 centimeters. Now this was a really long process for me to do this. You should be able to do some of this in your head once you get used to working with units. But if you get confused, you can fall back on an equation which converts one metric unit to the other. Measuring volume. You may remember from math class that you measure the length times the width times the height in order to get volume of a rectangular cube, right? So if I was to measure, say, a swimming pool that had these dimensions, say it had a length of 10 meters and a depth of 3 meters and a width of 5 meters. Could you tell me what the volume of that swimming pool is? Right? So it's length times width times height, which is 3 times 5, which is 15, times 10 is 150 cubic meters, right? Because it's a meter times a meter times a meter, that's a cubic meter, right? Now could you tell me how many liters of soda pop it would take to fill our swimming pool? Well, if you knew that in 1 cubic meter there's 1,000 liters and we had 150 cubic meters, then we would need 150,000 liters. So liquid is measured in liters in the SI system of units. Another important relationship is 1 cubic meter is equal to 1 milliliter. You may recognize milliliters as, say when you're taking NyQuil or something for a cold, a liquid cold medicine, quite often that's dispensed in milliliters. 50 milliliters is, I don't know, 1 or 2 tablespoons, and that's, the dose that you would take for some cough medicine or something like that. Important relationship between milliliters and cubic centimeters. Right? I want you to have that in your notes also. I hope you're keeping up with your notes, because every time you see a major point up here, that should be a major point in your notes, and I will be checking those. The next thing we're going to talk about, and the next major point in your notes, is measuring matter. Everything is made up of matter, and that matter has what we call mass. And so when we mass something, we're determining how much matter there is in that object. So you might be familiar with a scale that we will use to mass objects with, or to weigh, you might think of it. But weight is a little bit different than what mass is. We'll be talking about that later. But mass, the standard unit for mass is a kilogram. Right? And this scale is actually calibrated in grams, but you know that 1,000 grams is 1 kilogram. So if you needed to convert to kilograms, you could, right? And the last thing I want to talk about is derived units, because there are some units that we're going to be using a lot that aren't the base unit. They're actually a combination of base units. And whenever we combine 2 units to make another unit, that's what's called a derived unit. So density is a primary example of derived units, and density is the mass over the volume. And I like to say that density is the broken-hearted unit, because density is equal to the mass over the volume, and it's a broken heart. Can you see that? Heart broken. Okay. So one of the first projects that you're going to be doing is you are going to be determining the identity of an unknown substance. And the way you're going to verify the identity of that substance, you're going to predict what that substance is because you're going to measure the physical properties of that substance. And then you're going to compare those physical properties to the physical properties of known substances. And so if you say, hey, well, if my object has a density of this, and that's the same density as this stuff that we know of, then you'll be able to tell me, hey, I think that the stuff that I've been working with is this. So we're going to be working with density a lot. We'll be measuring the mass of your objects, and we will be measuring the volume of your objects. And if we know the mass and the volume, then we can determine the density. And if we know the density, we might be able to figure out what that stuff is that you have. Okay, so that's my mini lesson on SI units. And what you're going to do is, at the conclusion of this video, you'll be presented with a question, and you'll answer that question, and you will also write questions, any questions that you have while I've been lecturing here that you haven't been able to ask me, obviously, because this is pre-recorded. But if you did think of some questions, and in fact I want you to, in fact I require you to write some questions and bring those to class. And you can write those in your Cornell Notes. You remember, you write your questions on the left-hand side of your notes. So I want you to think right now, look over your notes and think about what you've written. And if there's any questions that you have remaining, or think of a question that you have and write that in your notes and bring that to class, and we will discuss it. Very important that you come to class with questions about this lecture material. So that's my presentation of SI units, and I'll see you next time.